Hi Algebra 2. So this is just a quick video about compound inequalities, and this is specifically in Chapter 1, Section 6, I believe. Specifically, this video is about and versus or compound inequalities. What I'm going to show you is just a few quick examples, not the algebra associated with the answers. Notice there's nothing to solve with these examples, but just some different answers you could have with these. So real quick, the difference between these two. And means that when I have two pieces involved, both must be true. So I only want to know where my answers are such that both pieces are true. If it is or, I want to know where is either true, really. So it could be both, but it could just be one or the other. So what this worksheet is real quick is just a couple examples. I have and inequalities on this side and or inequalities on this side. So I'm just going to go through a few of these so you can see some examples. So when we have a compound inequality written like this, what I want to do is break it apart to see what this is really saying, to figure out if it is and or if it is or. So what this is saying is two things. 4 is less than or equal to y, and it's also saying y is less than 7. Now, because it is written squished together like this, I'm going to assume it's an and inequality. But that doesn't necessarily mean I have any answers. So let's see what this means. The question is, can I have both of these be true at the same time? Can I have y values that are bigger than 4 at the same time that I have y values that are smaller than 7? And the answer is yes. It happens when I have values that are in between the two of them. So if it is less than or equal to, I'm going to put a filled in dot at 4. If it is just less than 7, I'm going to put an open dot. What that means is this: 4 is an answer. I'm allowed to use 4 and it will work in this inequality. 7 is not an answer. 7 will not cut it for me. 6.9 will cut it for me. 6.999 will cut it for me. They're all in between 4 and 7. So I'm just going to shade. Those are my answers. So any single number that's in between there, those are all of my answers. And I'm allowed to do that because this is an and inequality, where both of these happen at the same time. Now, let's take a look at this next one. It's smushed together, written like this, so I'm going to assume it's an and inequality. But let's see what this is saying. This is saying I want 2 to be greater than all of my x values, as well as I want x to be greater than 7. Let's think this through. I personally think this is funky to look at, so I'm just going to flip this around. X is less than 2. I want x values that are smaller than 2, as well as x values that are greater than 7. This is not possible if this is an and inequality, which it is. I cannot have numbers that are simultaneously smaller than 2 as well as greater than 7, meaning we have no answer. So on my number line, I'm not going to show anything because there is no such number that fits both of these things at the same time. Moving on to the last and that I want to show you, and has an orange dot on it. You'll see that why that has an orange dot in a moment. I want to know where I have numbers that are smaller than 9 and also smaller than 13. Notice on this one, you actually see the word and. That happens sometimes. So if you see it, you know right away. Or you also know that for and, if it's squished together, like either of those two, it is an and inequality. So for this guy, I'm going to use my pencil to show the shading on this one because I'm going to erase some stuff actually. So here we go. If I want x values to be smaller than 9, I'm going to do an open circle and shade that direction. I also want x values that are smaller than 13. Now, yeah, I'm still using my pencil on this one. So shade, shade, shade. Notice they overlap each other a little bit. In this region right here, only x is less than 13. Oop, you guys can't see that, sorry. Sorry, right there. In this region in between, only x is less than 13 is true. But in this region, sorry, lights just went off in my classroom. There we go. Sorry about that. In this region over here, both of these statements are true. X is less than 9 and x is less than 13 are true, meaning I only want the place where they are both true because this is an and inequality. So I actually don't want any of this because both of those pieces are not true. I do not want where they are both not true. So then, also, I need to unfill in my dot. Notice that for this one, 9 is not included, but for this one it is. But because it's not included for both, I can't include it in my answer. So I'm just going to unfill in that circle, redraw it so it's seen. There we go. So that is my only answer. So x is less than 9 is it for my answer. That's all I can include. That's the only way numbers down here, so 8, 7, 6, 5, all of these numbers down here, is the only way that I can have a number that satisfies both of these conditions at the same time. So that is it for and inequalities. Let's go through or. Or in math is a little bit more forgiving. We just care about where is this one true, where is that one true, bring it all together. So here we go. If x is less than -1, I know that looks like that, answers that are down there. Or x is greater than or equal to, so I'm going to fill it in, greater than or equal to 4. Now, I can't have both of these happen at the same time. I can't think of a number that is less than -1 and also greater than 4, but that's okay because it's or. So I don't need both to be true. It can be separate like that. Let's go to the next one. This should look familiar. Orange dot. This one down here, except it was an and inequality this time. Now I am doing an or inequality, meaning I do not care about them together. I just care about them separately. So here we go. If x is less than 9, that's some of that. So all numbers that are down that direction. If x is less than 13, that is some of this. Notice, again, they overlap. This happened in the last question that we talked about down here. But this time, I don't care that only one part of it is true in this section. I do not care. It does not matter to me. As long as one of them is true, it's included in my equation. So what this is saying is this. 13, again, open dot, is not an answer. But 12, 11, 10, like 10 and a half, all of these guys in between are. 9 is actually included now because 9 is less than 13, as well as 8, 7, 6, 5, all of these numbers. So all of these numbers down here are less than 13. Some of them are less than 9. I don't care that they are not both true at the same time. I just need one of them to be true. So my final answer is any number that is less than 13 will satisfy this full inequality because they do overlap a little bit. Let's go to the last one. I want numbers that are either less than 9 or greater than 5. Again, or, I just need to know where both of the answers are. I don't care where they are both at the same time located. So here we go. Less than 9, open circle there, shading it to the left, so all the way down there. The other one, x is greater than 5, so right here, all the way greater than up. Notice, because it is or, I don't care where they overlap. I just care where anything has been shaded at all. If I have a number like 0 down there, 0 is less than 9, so that counts in my inequality. Right here, 7 maybe. 7 is less than 9, so that counts. 9 itself is greater than 5, so it counts. 12 is greater than 5, so it counts. Notice there is not a single number that won't fit in one of these inequalities. Therefore, my solution is all real numbers. Absolutely every answer will work in this inequality because it is OR. Like I said, OR is very much more forgiving than AND. Remember, in AND, at one point we had this situation up here where we didn't have any answer at all, and that happens sometimes too. So hopefully that video helped a little bit distinguish between AND versus OR inequalities. Again, and where are both of my pieces shaded? Where are both parts of my inequality true? Or, much more forgiving, where is either of them true, and sort of combine it together and get a big conglomerate answer. There we go. Hopefully that helped. And if you have any questions, ask me in class.